a constructor of a circle, you can't do it. So yesterday's solution was to change the scope of the original variables from private to protected. Today we'll learn about another way to circumvent this problem, which is to call the constructor of the shape class. So the idea is the properties that belong to the shape class should only be touched by the shape class. And it's not a good idea to change the scope of these variables so that you can have access in the derived classes, just so that you can change their values once and never touch them again. So the way that we do it is like this. So this is still the same shape class with the constructor. We set two values. In the circle class, we call the constructor here. So this is where you put your initializer list, and you can also put the constructor of the original class as well. So in here, you provide the values that you provide to circle will be sort of reroute to shape, and they will be set by the shape constructor. Circle doesn't do anything there except calling the constructor. But this is a much nicer way to encapsulate your data. Basically, you separate your concern. The shape deals with the point of origin, which is represented by mx and my, and the circle only cares about the radius. Anything that deals with the point of origin should be dealt with in the shape class, not in the circle class. Alright. So let's do some small exercise. Now, if you're not using an IDE, then I highly recommend using an IDE. You can't see anything, can you? So this is my favorite IDE. It's called C-Lion, and if you use your email, your messy email, to register your account on just JetBrains website, you can have access to this for free. Otherwise, it will cost you like $100 a year. So this is the original code that we looked at yesterday. We have a shape class, right? It has a constructor that will set two variables. Now we have a circle class that inherits from shape, and it attempts to set these two variables in its constructor. But this is not allowed. Right? You can't even compile this. And a decent IDE will tell you that this is wrong. So if we try to compile it, it will say mx is a private member of shape, so you don't have permission. Right. So if we change this from private to protected or public, it will compile. Nothing strange happens. But we don't want to do that, right? We want to separate the concern of these variables from the derived classes. So instead of doing this, we'll call the constructor in the initializer list. And you do that by putting a colon before the curly bracket. You call shape x, y. Right, so this will work. It will compile, and it will print out the correct. Well, not really, but it will print out something. Alright, so that's constructor and how to invoke a constructor from the derived class. How to invoke a constructor of a base class in a derived class. Do this here. Now you don't have to do it here. you don't have to use the initialize the list. You can put it in here as well, but then you have to do things like shape and X and Y. I think that should do. Yeah, this should work as well. Nope, it doesn't work. Forget what I just said. Alright. Right, and in case you have a multi-level relationship between classes, let's say you have class A is the base class of class B, and the class B is the base class of class C, and the constructor of C should only call the constructor of B, shouldn't call constructor of A, even though it is possible. But it shouldn't. The reason is when you call, we will come to it later, but when we call the constructor of a derived class, this is a constructor of the base class. When we call the constructor of the derived class, it will call the constructor of the base class as well. So when you have something in between, let's say C inherits from B and D inherits from C, when you call D, without doing anything, C constructor will be called, and then B will be called. So if you want to affect the behavior of calling the constructor, you should do it only at one level up. So this will call some constructor of B. If you do it again here, then this might be called twice, and there will be unintended consequence of that. So now we come to the order in which the constructors and destructors are called. Why isn't there a destructor section before this? So let's talk about constructor first. As I say, if you have a class A that is a base class of class B and class C being the derived class of class B, then when you call C, this will happen. When you call C, it will call A first, and then it will call B, and then it will do whatever you have inside its constructor. So I'll write down the order to call is from top to bottom. Top to bottom. Now the constructor is a special function in a class. There's another special function which is a destructor. And the destructor is called when an object is out of scope, or if you create it, if you allocate its memory dynamically and you call and you use the keyword delete, then when let's say A goes out of scope, then a special function called destructor of A will be called. And if you have a normal class with no memory allocation, then this is basically doing nothing. But if you allocate memory within the class, let's say you have an array of int in the constructor will allocate some memory for this array. If you don't sort of reclaim this memory when the object is out of scope, then the memory that you occupy will stay there forever until the program finishes. So in order to avoid that, we need to reclaim the memory in the destructor. Equal to reclaim if necessary. And the order in which this one is called is the opposite. So when you call the destructor of A, run the code first. So A3. And here we have class A. Class B derives from A. Class C derives from B. Right, so when A is constructed, it will print out A created. When it is destructed, it will print out A destroyed, and so on. And same to B and C. Right? And here I only initialize C. See what happens. Yeah, so the order is from top to bottom. Even though I only initialize C, A and B get called as well. And the order in which they are destroyed is the opposite, right? So when you call the destructor of C, the first thing that will be called is obviously itself, and then the destructor of the immediate base class, which is B, and B is also a derived class of A, so B will call A. A is a derived class of no other class, so it will stop here. Right. Now, let's go back to this example. So in here, in the shape class, I have a print function, right? And circle inherits this print function automatically. That's why I can call c.print down here. And then this function will do this. It will print out mx and my. But because it is a circle, I want it to print out the radius as well. So what do I have to do? I have to override it, right? Void print. Same name, same parameters, but different behavior. Right, so obviously I can do this. If this was protected, then I can do it, right? But it is not. So what I can do is to invoke this function from the base class. First I will call shape like that. So it will print out this first two number, and then I will print out my own radius. So when I do this, I run the program. So this is the behavior of the shape, right? It will print out mx and my. And this is the behavior of the circle. It will first call the print function of the base class to print out mx and my because it doesn't have access to these directly. And then it will print out where it has x. And it will print out radius. So this is all fine and dandy, except that when you have a base class and a derived class, you can actually treat the derived class as a base class. And that is the meaning of polymorphism. Polymorphism is, poly is many and morph is form. Right? So when you have a dog, you can treat it as a mammal. Right? So any disease that affects mammals can affect dogs as well. And when you treat a dog for diseases that are related to any mammals, then you treat it as a mammal. So in general, if you have a derived class, you can construct a derived object, but you can treat it as a base object. So this object, we have one object, but we can consider, sometimes we consider it a derived class, sometimes we consider it as a base class. It has two forms. Right, so that's the meaning of polymorphism. And the way that we do it is to declare this object to be of type shape. So instead of this, I can declare shape C. But obviously, if it is a shape, I can call a constructor with 3 arguments. Right? This is a constructor of the circle. So I have to do it sort of indirectly by calling it by allocating its memory dynamically. Right, so when we do this, let's just comment out. When we do this, we construct a circle with these 3 arguments. So in the memory, you will have a circle, but you assign the type of it, the type of the variable to be shape. So when you deal with C, let's say you call C.print, the compiler will consider C to be a shape instead of a circle. Right, so let's see what happens. And one thing to remember is when it is a pointer, you cannot use a dot notation, you have to use an arrow notation. Right. So let's recall previously when we have a real object shape and a real object circle, object prints shape prints out 1, 2, circle prints out 1, 2, and 3. Right? Now we have a object circle, but we treat it as a shape. So the behavior is gone. The behavior of the circle is gone. Now I only have the behavior of shape. Right. So that's obviously we do want to have the behavior of shape, and we can fix this problem by using something called dynamic binding. Binding is basically tying the name of a function to the address of the function in memory. When you have a C object, circle object, it has 2 function print actually. It will have shape print, and it will have circle print. If you treat C not as a circle, but you treat it as a shape, right? The compiler will sort of ignore it. It only see this one as shape, so it finds a function called print in the scope of shape. And so yeah, here's what I find. So let's use this. And this is all done statically, static linking. So the moment that you write that piece of code, it will say, because C is a shape, I will link it to this function at the compiling time. But if we want to really invoke a function that belongs to the circle aspect of it, we have to say, hey, hang on. Even though you do find a print function in the namespace of shape, and it is a shape, hang on, don't call this function as now. Let's search for more. Right? So what is the real type of C? This is the pointer type. But the real type of C is circle. Right, so hang on, don't call this one yet. Let's look at the real type. Right. It is a circle. Is there a function called print in the namespace of circle? Yes, there is. So instead of calling this, we call this. And this is called dynamic linking. It is called dynamic linking because it cannot be done at compiling time. And it can only be done at runtime, because only at runtime you know what is the real type of an object. at compiler time, all it sees is shape C, which is a shape, not a circle. Right. And the key word for saying, hey, hang on, don't rush, in C is virtual. When you declare something virtual, basically you say, hang on a minute, don't call me as yet. So let's come back to the code. We declare, so this function will be found first, because the pointer is shape, so it will first find anything in the shape namespace. If we want to say, hang on, don't do anything yet, we have to say, use this keyword. Right. So this keyword will say, even though you find the sprint function, let's find some more. Right. Now, if I have this, I get the behavior of the circle back. Right. So this point is extremely important. Is there any problem, any question? Yes?
Why would you go to trouble of defining it as a circle, but then clearing it as a shape,
Yeah.
and then you have trouble with invoking virtual function?
Yeah, very good question. Very good. Because sometimes I have no choice. I have shape, and shape can have multiple children: circle, rectangle, square. You get the point. If I want to have an array of shapes, I can only have an array of circle or an array of rectangle and an array of square. Or everything in an array must have the same type. So if I want to have an array with 3 of these objects, I have no choice but to treat them as shapes, because now they are the same type. So you will often write code like this: base pointer array equals new base, let's say 10. Actually, it should be 2 arrays. Might be too complicated. And then you say base number 1 is new derived. Or actually, I'm going to use this example. You have an array of shape. So you have 10 shapes, right? And then you say the shape number 1 should be 0. It's going to show this array. The first item in the shape is a circle. The second is a square, and so on. So it is absolutely necessary to have this possibility to represent objects as a base class instead of as this class. Any other question? So the point of the point about virtual is extremely important. We need to understand that before we can move on. No other questions? All right. Okay, again, polymorphism is many form. Right, so in here I have a square, which is a shape. I can declare a pointer of type shape to a circle. I can make an alias of type shape to a circle, and so on. Is it confusing? Now I find it helpful to sort of write these notions, these symbols in a particular way. So this symbol actually has 2 meanings. This symbol has 2 meanings as well. And you read them differently. So when you have a type of a pointer like this shape, I find it useful to write the asterisk right next to the name of the type, and then a space. and then the name of the pointer instead of that. And then this will read as P is a pointer of type shape. However, when you use P after declaring it like this, then this is not a pointer anymore. This is an object. P is an object. P is not a pointer anymore. The same to the ampersand. When you declare, when you write like this, it is a little bit more difficult to interpret than writing it like this with a space. When it is like this, you read R is a alias of type shape to an object. Right? But when you use R down in the code, you write this, and this is no longer an object. This is a pointer. So because it is a pointer, you can do things like this. And because asterisk P is an object, you can do things like this. But yeah, be careful with how you write that ampersand and asterisk. When you declare it, try to put this asterisk and ampersand next to the name of the type. When you use the variable, put it next to the name of the variable. That will be a little bit more useful and less confusing to look at. But this says we create a circle, and we create a square, and then we will sort of create another pointer that points to the same address. Right? So this is the address now. It's no longer alias. Pointer P points to the address of C. So different pointers, but same object. So I can call C, in which case it will be considered a circle, or I can use P, in which case still the same object, but it will be considered a shape. And same, yeah. Okay, confusing. I guess I'll come back later. Yeah, right. So when you create something as a derived class object, but you reference it using a base class pointer, then the compiler will always treat it foremost as the base class. And if you have a virtual keyword anywhere in the code, then it will sort of try to search for more. It can do that because we know for sure that if you have a base class and you have a derived class, you can declare as many more functions or variables in the derived class. But the original functions and original variables in the base class will always be there. They cannot go away. So it is safe to treat a circle as a shape because you know that the point of origin is always there. But it's not safe to treat a shape as a circle because you don't know if the radius is there, right? So if you do something crazy like this, circle C equals new shape, right? The compiler will reject this line of code. Right. So this sort of demonstrates the importance of having the virtual keyword. When you don't have a virtual keyword and you treat, so P is a pointer to C, C is a circle. When you treat circle as a circle in here, it will print out all the information of a circle. When you treat it as a pointer of a shape, when you treat it as a shape, and you call it here, it will only print the information of the shape, not of a circle. And we learned how to avert this problem by having the virtual keyword. virtual. And you declare virtual when it is in a place where it is first searched for. So if you use circle as a shape, then the compiler will search this line first. If it sees the keyword virtual, it will sort of say, okay, hang on, I'll search more. So if you declare this not without the keyword virtual and you declare virtual here, it has no effect at all. Because if you don't have the virtual keyword there, the compiler will stop as soon as it finds the print function in shape. Right, so now with the virtual keyword, we get this. Even though it is treated as a shape, it is still prints out all the information of the circle. Again, is there any question? Understood? Yeah. All right. So this is a tricky question. Right? So previously we know how to refer to an existing object using the base type. If you have a circle, right, somewhere, you can refer to it as a shape like this. So this is an existing object, right? And this is a pointer. That's fine. But what happens if you forgot to use these symbols? This is no longer a pointer, it is a new object. P is now a new object. And what does it mean when you say object P is C? And what happens when you call print function from the newly constructed object? So what happens is, I think we will learn sometime next, after the break, is that there are different types of constructor. There's a special constructor called a copy constructor. When you do this, because this is a new object, it needs to be constructed. And this says construct this new object using all the information here. So the copy constructor will sort of go into the scope of C and see what variables are there. And if there are variables that have the same name, same type in P, the values of those variables will be copied from C to P. So you will end up with P having the same information as C does, but it doesn't have all the information, all the extra information that C does. Because shape only has mx and my, C has mx, my, and radius. So only the mx and my will be copied to P. Radius will not be. Right. So when you call this, obviously this is a shape. It is truly a shape, it's not a circle. It will print out only the first two numbers. These two numbers are copied by this line, and then they are printed out by the print function that belongs to the shape class. Right. Any question here? I probably will learn about copy constructor later, but you get the idea. So if you want to refer to something that already exists, don't forget to use all of these symbols. They're quite important. Or something like this, UC, whatever. But this is important. Yeah, so this is the proper way to refer to a derived object as a base class. Right, now it comes to something that is even more important than everything I said was important. The order in which you call the destructor is that you will call the destructor of the object. If you have a circle, C, and you call delete C, then the order in which the destructor are invoked will be, first it will call C. So it will call the destructor of C, or circle. Right? And then because C is a derived class of shape, it will also call the destructor of shape. Now, the reason why it calls this first is not because C is an object of type circle. It is because it is a pointer of type circle. So be very aware of this. An object has a concrete type, and it also has a pointer type. So any function that you call from a pointer of type x will first be searched in the namespace of x. Right? So the reason why circle, the destructor of circle is called here first, was because it is represented as a circle. So it will search in this namespace. Now let's say we have a circle, but we refer to it as a shape. And you call delete C, the destructor of C will not be called. Not be called. Because the compiler sees that this is a shape, there's no reason to destruct something other than a shape. Make sense? So it will search for a destructor in the scope of the type of the pointer, not the type of the object. Yeah? So C is a circle, it does have its own destructor, but because it is represented as a shape, the compiler will search for the destructor in the shape of a namespace. Right? And if you declare something here that you need to clean up, it will not be cleaned up. So we need to somehow force the compiler, or force the computer really, to call the destructor of the object instead of the pointer. And how do we do that? We do the same thing that we did with the print function. We declare the destructor virtual. Right, so let me demonstrate that here. A4. Right, so in here I have class A and class B. So class A has a array dynamically allocated by the constructor. Yeah? And when it is destructed, it will be reclaimed, the resource will be reclaimed. So everything is fine there. Same to class B, it has its own resources. Now because B is a derived class of A, it will also have A resources as well. But this is everything that it has access to. So in the constructor of B, it will allocate memory for B resources. And in the destructor of B, it will reclaim B resources. So we can construct a B. If we just have a B, see what happens. Right, so because B is a derived class of A, the constructor of A will be called first, right, to allocate memory for A resources, and then the constructor of B will be called after that to allocate memory for B resources. And then B goes out of scope, the destructor of B will be called first to release this resources, B resources, and then A will release A resources. Everything is fine then. However, if you refer to B as an A, right, so A, B equals new B. So in the memory, we still have a B. We don't have an A, we have a B. But let's see what happens. So we construct a B, but we refer to it as an A, and then we delete it. So let's see what happens. So we do this all the time. So first, it was constructed here. So the construction is no there's no problem there. A will be called first to allocate A resources, and then B constructor will be called second to allocate B resources. But when we delete B, because it is referred to as an A, only the destructor of A is called. And whatever you allocate here will not be called, and you will have a memory leak. So it is vital to always declare the destructor virtual. In fact, there is no reason not to. When you declare a constructor virtual, and when you create a new class, have a habit of always declare the destructor virtual, even if there is no derived class, right? Because in the real world, you can create a library, and someone can derive classes from your existing class, and you want your class to be smart enough to call the destructor of the derived classes instead of its own. So when you do your assignment, always do this. Even if there is nothing that inherits the class, always do virtual destructor. That's what it is. So here, what else? Right, this is probably some summary. Right, so the constructors are called from top to bottom, and the destructors are called from bottom up. The destructor will not be called automatically if the object is dynamically allocated like this. In this case, if I don't call B, the destructor will never be called. So the memory will, well, when the program goes out of scope, the operating system will still reclaim the memory. But let's say you have something else down here, you want your memory to be clean rather than having something that shouldn't be there. So if it is a pointer, always use the keyword delete. See, yes, we still have some. Sure. Right, so something for you to remember. So constructors and destructors are special functions of a class. They cannot be inherited. They cannot be overwritten. But the constructor cannot be virtual, because when you construct something, you must use the keyword new and the actual name of the object. Right? So new circle equals shape something, but you always use the keyword new with the actual type. So there is no possibility of making it virtual. But the destructor can and should always be virtual. Have a habit of making it virtual all the time. All right. So yesterday, someone asked me about this question. When you have a base class and you publicly inherit base class in a derived class, and the base class has a bunch of public variables, is there any way to inherit everything public except for some? Right? So there turns out there is a way, and this is a way. So you still publicly inherit base in derived. So naturally, all of these will still come to the scope of derived as public variables. But you say private using base x to say, hey, all right, everything else is public except for x. So x is from now on private. And if you have a derived second that derives from derived, that one will not inherit x. So yeah, that was a good question. Let's see if I can run this thing. Right, so what happens when I click the run button? I have a base, so base has all of these variables public, so there's no problem here. And then I have derived say everything else is public except for x. And then I try to do this. The compiler will complain, it will not compile. Like that, it will say, because x is now a private member of derived, right? Will not compile. However, if I represent D as a base, so I have an object D of type derived, and I say base fec D, right, equals D, and I call fec D no problem. I have that object of type derived, which theoretically I shouldn't have access to X at all, but if I dress it up as a base, then I can still do everything I can with the base. So even though this is possible, it's not a good idea. You make it private, but there is a way for your user to simply convert it to something that they can access. So this is not a good idea. If you want something to be private, make it private in the base. All right. So is there any other questions before we end the lecture? No? Okay, good. Have a good tutorial tomorrow, and enjoy the break, and we will see after the break. Again, if I have time during the break, I will mark your test, but if I don't, then it's going to be a little bit longer than 2 weeks.